In this tutorial, we will use the circular velocity expression to answer the question, what is the orbital velocity of the Moon in its orbit about the Earth? So what is the velocity of the Moon? Alright, so we'll use the circular velocity expression that you can find in your textbook. So this is given by the gravitational constant, capital G, times the mass over the orbital radius, and we'll take the square root. Now the key thing is to understand what each of the terms means. So here's our equation, and let's check each term. So G is this constant, and it is 6.67 times 10 to the minus 11 meters cubed per second squared per kilogram. And the units are important in this formula. Okay, next up is the mass, and it's important to understand which mass this is. Even though we're interested in the velocity of the Moon, it's the object that is being orbited that matters. So this is the mass of the object being orbited. Okay, and if we're interested in the Moon's orbit about the Earth, then this mass is the mass of the Earth, not the mass of the Moon. And so the mass of the Earth is 5.97 times 10 to the 24 kilograms. So whether it were our exact Moon orbiting the Earth or a different object in the Moon's orbit, the mass that would matter is the mass of the Earth. So next, there's the radius that we need to know, and in this case it's not the radius of the object, it's the orbit radius. Okay, so that's the Earth-Moon distance. And in this case, it's 3.84 times 10 to the 8 meters. And let's take a second look at the units, just to be sure that's clear. So if we look at the gravitational constant, we notice that there's a term involving kilograms. So that means that our mass needs to be expressed in kilograms so that they match. Similarly, the gravitational constant has a unit involving meters, and so that means our radius needs to be expressed in meters as well. So if it had been in a different unit like kilometers, that would be fine. You would just need to convert it before using this equation here. Okay, so now let's go ahead and put those values into the circular orbit equation. So the circular velocity is given by the square root of the product of the gravitational constant, so that's the 6.67 times 10 to the minus 11, and we'll multiply that by the mass of the Earth, so the 5.97 times 10 to the 24. And then we'll divide that number by the radius of the orbit, so the 3.84 times 10 to the 8. And that gives us, we'll do the value on the top first. That gives 39.8, so you can check with your calculator, and this is in the textbook as well, so you can see the numbers to follow along. 39.8 times 10 to the 13 divided by 3.84. Nothing has changed in the denominator, 10 to the 8, and then we'll take the square root of that whole expression, and that gives us the square root of 1.04 times 10 to the 6th. So when we take the square root of that, that equals, our circular velocity here, equals 1020 meters per second. And then we can go ahead and okay, so we can also express the circular velocity, instead of in meters per second, in kilometers per second, by shifting the decimal point over 3 spaces, and then we would have 1.02 kilometers per second. And so that is the velocity at which the moon moves in its orbit about the Earth.